Hi everyone. We had some small technical difficulties before we started this live. So hi again and welcome to Talks 141. I'm your host, Radu Sebastiana Maria, and tonight it's the last edition before the Christmas holiday, in which I hope you all will enjoy, although we are sort of quarantined. Besides that, today is also a special day for someone important to this community. I'm talking about Softbinator's Foundation co-founder, Daniel Ilinka. So Danny, if you're watching us live, happy birthday and may all your wishes come true. So yeah, going back to our special talks, before the Christmas edition, we have an international edition again with two great speakers joining us tonight. One is from Israel and the other one is from Germany, and they'll help us better understand topics around big data and web development tonight. So let's welcome our first speaker for tonight, Etti Gur from Israel, which is a highly experienced developer with over 20 years in the software industry, with the last 8 years working as a senior big data developer for Nielsen, building big data pipelines with Spark, Kafka, Druid, Airflow, and more. And apparently she still has some networking issues. Tonight she'll be talking about optimizing Spark-based data pipelines. So if you have any questions for her, just add them in the comments on our Facebook live feed that you can find on our Softbinator Foundation page, and I'll read them out to our speaker. So we'll wait a couple more minutes for her to join back. If it's still not great, then maybe our next speaker, Stefan Judis, which will be joining us from Germany, and it's developer relations at Contentful. He'll be talking about the state of the web technology and if did we and web development route the right direction. So we'll wait a bit more for Etti to join us. Okay, so we still have problems with Etty, so we're gonna swap her with Stefan. Hello, Stefan. Hello from Germany. How
How's
are you?
life? I'm
Uh,
pretty good. What about you?
Good, good. Looking forward for your amazing talk. So, your developer relations at Contentful, and you have some pretty hard question for all of us that do web development, including me. uh,
hmm
if we're on the right track. Can you tell us a bit about you and how did you end up doing web dev and what is your topic for tonight?
Well, I do software development now for 10 years. I started a little bit with, I will cover a little bit of that in my slides too. So I'm doing software development now for 10 years. I was in several companies here in Berlin. The startup hype, I was all there. led a team at the end, and then now for 3 years I'm working in developer relations, which means making developers happy, which I do now for a living. And today I'm going to talk about front-end web development and maybe the fact that we're doing the wrong things.
For sure, we are doing some wrong things, especially with all the package managing that end up hogging gigabytes for just some simple web pages. I'll let you go into it.
Cool. Should I share my screen?
Yeah, sure.
All right. Then here we go. And now I'm pressing play. Does that look good?
Yeah, it looks perfect on my side.
Well, then I'm going to kick it off. What do you think?
Yeah, perfect.
Cool. Hello, everybody. I'm Stefan, and I want to ask you if we if we did lose the right direction in web development. And you see it maybe here, I'm wearing my JavaScript fanboy hat, and it might be perceived this talk that it's a long, big rant, and I still do love JavaScript. So let's just dive right in, and let me tell you that this is a talk about general best practices in 2020 and 2021. And I'm Stefan. I work for a company that is called Contentful. So in case you're building things in the front end layer or even on the server side and you're looking for an API first content management system that you don't have to host, that you don't have to worry about, and actually only what you want to deal with is some pure data that people can edit, well, then you can give Contentful a try. And when I started doing web development, which was almost now 10 years ago, I did an internship here in Berlin at an e-commerce company. And I was studying computer science on the side. And the tech stack that I was confronted with was basically MySQL, Apache, and PHP. And in the first few weeks of my software internship or my internship at this company, I was already incredibly overwhelmed because the developers there dealt with a terminal and they knew about certain things about servers, and PHP by itself was a challenge for myself, and server configuration, oh my goodness. And I felt like, oh my God, you will never know that. And then moving forward, I specialized a little bit more into the front-end layer at this company, and we had prototype and jQuery in there. Just because more is always better, right? For the people that do front-end development long enough know that prototype is basically the same as jQuery. It was a Magento shop. And then slowly but surely, we moved more things into the client using a new fancy thing that was Backbone.js at the time. And more things moved into the client side, which then meant that we slowly but surely collected new rules and sets of general best practices to build for the web. So what you see here is YSlow, and YSlow was basically one of the first collections that included a rule set of what it means to build something fast and good for the web. And as probably a lot of people, or a lot of you do, is I also had the dream of becoming a blogger. So what you see here is my first blog. I decided with my colleagues that we wanted to blog on this domain. We made it, I think, to 6, 7, 8 posts. I'm not blogging there anymore. It was built with Jekyll. It worked. I never was a good enough Ruby developer to really understand what's going on. And then something crucial happened with these two things. So Grunt and Gulp were the first tools that brought more power into front-end developers' hands to concatenate and crunch and do more operations with JavaScript and front-end related assets. So I moved on. I did a little bit of Angular 1. I then did React and Vue for a little bit. And I really can tell you that I love this field and I love technology and I love writing JavaScript. I started a different blog at some point, which is my own blog. So you see here how my blog looked like from 2017 to 2020, and it looked fancy, it performed fairly well, and it was using a cutting-edge JavaScript framework. And I spent hours and hours and hours tweaking this blog. And when at the time I went into Google Lighthouse, which is a tool that is included in the Chrome developer tools, you see there that I had a fairly green score across the board. I was super happy with that. And when you care about web performance, you can also go to a service that is called Web Page Test. So you paste in your URL and then you get some nice performance metrics from real devices around the world. And you see there that my website was on a cable connection loading after roughly a second. So this is what the speed index is. It gives you a time and when most of the page was rendered invisible. So that was a second on a cable connection. And even on a 3G connection, I was somewhere between 3 and 4 seconds, which is pretty decent. So when you monitor your sites in Lighthouse, you can take this general rule that when you have a performance score that is above 90, you're usually in the top 5% of performing websites. And because I was using a cutting-edge JavaScript framework, I was also using recent hosting. I was also using a lot of goodies that we do these days. So everything was coming with HTTP2, everything was compressed and minified. I had a module and no module bridge in there to ship unpolyfilled JavaScript to evergreen browsers. I had proper font handling in here. Of course, I was preloading a lot of things to make everything snappy. And the overall code base was, of course, because this is how you do it in 2020, probably code split it. And I felt very, very happy with this piece of art of technology. And then one day, this site was trending on Hacker News. So what you see here is a random site from Italy. It looks a little bit outdated, but if I navigate around on this page, there's one thing that it is. It is snappy. And also, it still seems to be maintained, this site, which I think is very interesting. So when you look under the hood, what is included in this site, you see, first of all, that it's including a lot of GIFs. And the HTML in there is probably not the best HTML out there. But when you open this site in Google Chrome and you have a look at the Lighthouse tools, you see that it has a stellar 100 performance score. And even my blog that I was building when I was very early in my career was outperforming performance-wise the site that I was tweaking weekend over weekend over weekend. I could not believe that. So I went back to webpage test to /video. So when you go to this URL on webpagetest.org, what you can do is you can paste in several URLs and you get a video like that. And indeed, my beautifully crafted website using current technologies was outperformed by these old school sites. So you could now just say, Stefan, you just messed it up. And honestly, that could be. But the question that I want to ask you is, how can it be so easy to mess up? So I digged a little bit deeper and I had a little bit of, I had a look at the numbers of these three sites. So you see here that the overall page weight of my website is way, way heavier than the others. You see that my index HTML file is huge. CSS resources don't really matter in this context. And you also see that a static blog like mine at the time needs or loads 22 different JavaScript resources. Images also don't really matter in this case. But this combination of these red numbers there then lead to a worse speed index and an overall worse performance Lighthouse score. But how's Lighthouse calculating the performance score? So when you look a little bit into it, you will see that it's a combination of 6 numbers or 6 metrics. So you see here that it's 15% first contentful paint, which is the first meaningful thing that is printed to the screen. Then 50% time to interactive, which then means that the browser had the time to interact or react to user interactions. Then it's the speed index. I already explained that one. Then it's the largest contentful paint, which means sometimes you have websites that just load a chunk and then another chunk. And this is with the time when the biggest one appears. 25% of total blocking time, which is time that the browser needs to execute and run the JavaScript. And 5% of cumulative layout shift, which is usually the jumpiness of a page, because we all know that you want to press something and then an ad kicks in and you press something completely else. And 2 of these numbers are directly related to JavaScript execution because the browser is a single threaded environment and JavaScript blocks the main thread. If you want to learn more about Lighthouse performance scores, I can recommend these 2 resources. So it's a beautiful blog post on the Calibre blog written by Carolina. And if you want to know what it takes to receive maybe a 92 instead of a 91 in Google Lighthouse, you can open up this performance calculator from Paul Irish. But why are these JavaScript metrics so important? They're important because when we ship for the web, sometimes we ship experiences that people just don't understand. A normal non-techie person does not understand that they see a button and they click something and nothing is happening. This is pending JavaScript, because JavaScript has to be downloaded, parsed, and executed. And when you look at what we're building for the web today, you will find out that depending on the extremely wide device range of low-end phones, high-end phones, maybe old computers, you will see that sometimes the JavaScript that we ship to our clients takes 20 seconds to be executed on devices. So you see here a comparison of the websites that are built with React, Angular, Vue, and jQuery. And you see here that usually framework sites are a little bit heavier and take a little bit longer to be executed than others. And the question is really if we always need to ship that much JavaScript to our users. For example, Netflix did this little case study and they had a sign-up form. And when you think of a sign-up form, really what you need is email, password, maybe some validations, and then you send it to the server. And initially they built that with React. And they found out by just dropping React and doing a little bit of vanilla JavaScript without a framework, they were able to improve the time to interactive by 50%. Which at the end of the day, for a sign-up page, this is one-to-one your conversion rate. You always have to remember that 150 kilobyte of an image is nothing, really nothing compared to 150 kilobytes of gzip JavaScript. Page rate is really not equal page rate. And you have to think of that all the time when you're building for the web. So I had an index page of 340 kilobyte for roughly 400 words. What is in there? So, and I also hang out on Twitter quite a little bit, and the Twitter sphere asked me the same question. So how did I react to that? Back at the time in 2018, what I did is that I explained why there's so much stuff in there first. And I was saying to the person that I was following the new best practices and that I'm still lighter than the rest, and that this is how we build for the web today. So basically what I said is that it's great because it's fast and it's still lighter than the rest of the internet. But now 2 years in, what I can say is that I was getting into this argument because I was really just digging the tech stack. So I had a 300 kilobyte index file. What was actually in there? The main reason for that was this. So as mentioned, I was using a universal JavaScript framework that was doing server-side rendering in Node.js. And when you do this, or when you use this kind of architecture, you always have to inline the data in your HTML so that the front-end JavaScript knows what data was used to actually render this HTML. And super smart, past Stefan decided to preload and inline 22 articles at an average session length of 1.17 pages. This was all sitting in there inlined in a script block. And I did all that for better performance. So you might now say that in 2020, making a very fast website is extremely hard. And I want to question that for the next 20 minutes. Because is it really that hard? Phil Hawksworth from Netlify is also building a lot of websites, and people usually ask him how he's doing that it's that snappy. And his advice is usually that he keeps it simple, he pre-renders the HTML, he inlines some CSS, and usually the work for the browsers of our users was already done before they even get there. And I couldn't believe that. So I moved on and I built another side project. So what you see here is tiny-helpers.dev, and it's basically a resource collection of online tools for web developers. And I built this with 11t. So 11t is one of these new static site generators that is fairly fast and a little bit trending in the JavaScript ecosystem. But what is nice about 11t is that it's not adding any overhead. It is pure. It focuses on the rendering, and it's not adding anything that makes the website slow by default. And without doing anything, I hit this almost perfect Lighthouse score. And the 11t community is very proud of that. So what you see here is a screenshot of the 11t performance leaderboard. And due to the fact that this static site generator is not adding stuff, they make it that the median score, Lighthouse performance score, is an easy 100. I mean, this is beautiful and this is something to be proud of. 2 years ago, I was giving this talk at a conference in Oslo, and it was about the front-end development stack in 2018. And I said on stage in front of hundreds of people that every website is a web app and every web app is a website. And today, I could not disagree more with past me. Because where is the user's benefit of such overhead? So let's dive a little bit deeper and have a look at that. The first thing that I slightly touched is the new best practice of universal JavaScript apps for content sites. So when I started building for the web, what we had was HTML5 boilerplate, which was the way to go to build for the web. And we had a CSS file there and maybe 2 JavaScript files with render code and maybe with your main code. And this changed over the years now to have something like this code splitter that includes way more code. And we see here this included data block that gives you the data that was used to render the HTML. And by design, this is a beautiful architecture because the same code runs on the server and on the client. But at the same time, this means the same code runs on the server and the client. When you build your websites, you ship a lot of content in your HTML. And when you're not doing your templates very clean, or when you're dealing with a lot of data, you're shipping usually the same stuff in your JavaScript. You're multiplying everything with 2. And is this really the best way for the user? Every now and then I hear people talk about, well, this architecture is great because it offers doors to progressive enhancement. In case you're not familiar with the term progressive enhancement, let me just quickly explain to you what that means. So progressive enhancement basically means that you ship some base functionality, which is usually HTML, and then you sprinkle something on top of it, which is usually JavaScript, to get an enhanced experience. So you see here that stairs could potentially become escalators. And if the enhancement fails, everything is supposed to still work. But now let me ask you a question. How often do you see escalators that are blocked like this? Maybe this whole idea in this context is not working like at all. So if you want to know how this could look in detail, this is another side project that I did over time. And you see here perf minus tooling today. I'm not maintaining that anymore. But progressive enhancement was very important for me at the time. And what you see here is that there's a search box. And this works no matter what. So what you can do is you can interact with the search box, and it's updating the search results inline in real time with JavaScript. It's updating the URL so that when you do a refresh, you still get the same results because it's also server rendered. And then this is an actual submittable form. So when JavaScript fails for one reason or another, it will also still work. So that the user gets an enhanced experience when everything is there, but otherwise they can just move on. But you might now say, well, JavaScript is not failing to load, or nobody has JavaScript disabled. Depending on the product that you're building, you will find out that hundreds, thousands, millions of requests for JavaScript will actually just fail. Because we have this big question mark in the middle, which is the network layer. And you can always think about the fact maybe you're having a faulty deploy and everything just breaks because this is how JavaScript rolls. Then all your users are non-JavaScript users. And also you have to consider that every user out there is a non-JavaScript user while they're downloading, parsing, and executing your JavaScript. But it's not only me at the time that is using this principle to build for the web. So for example, when you go to GitHub and you want to post a comment on an issue, you will find out that this endpoint on github.com handles old school form submits, but also AJAX calls. So when the JavaScript fails for one reason or another, GitHub can still provide the nice experience. And even these 5 old school links just work out of the box without much fanciness. And I'm very happy with this experience because I believe that a good site should just work. So what's the enhancement that we see out there in the wild building stuff for the web in 2020? So I'm now showing you reactjs.org. I don't want to pick on React, but you have to pick something. So when you go to reactjs.org with JavaScript and you load it on a fast 3G connection, you will see that it loads fairly fast. And when you navigate around, you will see that the navigation is kind of snappy. But now let me do the same thing with JavaScript disabled under the same connection speed of 3G. you see that it's also loading fast and that the navigation is also fairly snappy. So there's no enhancement whatsoever. But when you look into it, you will find out that with JavaScript, React.js.org is loading almost 10 times more than without offering any benefit. And even after 4 navigations, the JavaScript version is still substantially heavier than the rest. And this is not only React developers or Vue developers. I'm guilty of that myself. I was doing that for years on my own websites because I liked the tech stack without offering any benefit for the users. So is this architecture really improving anything? Today, close to 2021, I'm not sure about that at all. What I am sure about though is that in certain cases, this can harm user experience. So in pre-COVID times, what happened is that I used to travel quite a lot. And what you see here is a screenshot of my mobile phone. And this is my mobile provider that tells me, well, Stefan, you just got out of a plane, you're in a foreign country, you're not speaking the language, and you now get 6 megabytes for €2, but you only have to use that, or you have to use that in 24 hours. This is a joke. And when I'm in the foreign country, this is really ruining my day because I have to find out where I have to go, how to find a cab, where my hotel is, and maybe I need some additional information. And when you think about the fact that the average website in 2020 reached an average or median size of roughly 2 megabytes, this is not getting me very far. We started to ship more and more data for a similar experience. And maybe it's time to consider our technology choices. Maybe app frameworks are for apps after all. I mean, Facebook is building Facebook with React. This is an incredibly complex piece of software. And for that, it might be okay to ship a lot of JavaScript. Another example out there is Gmail. I love Gmail. It's a Google product, but Gmail is a nice email client, and I like using it. When I load it on my computer, it's 5 megabytes. It's extremely heavy. And that's okay when I have the possibility to consume that much data at home. But Gmail also offers this low data mode, which you can access, and then you get more or less the similar experience with 25K to download. So you can have an experience, an enriched experience when you want to, but also you can go to the lower end or the low budget version if I'm sitting in a train with a spotty Wi-Fi connection. And overall, when you look at a few statistics, it always feels like everybody's doing React, Angular, Vue, Svelte, and whatever is trending in the newsletters today. But at the end of the day, 85% of the web is still running on jQuery, and it still works. And the overall distribution of frameworks is not as much as it always feels like. React overall has 5% of the web. So you see here statistics from the Web Almanac. And just recently, like a week ago, they released the 2020 edition. And you see still that 83% of the web run on jQuery. The web is not as cutting edge as it seems. And really, the mantra should be that boring is beautiful and fast. But when you're using a JavaScript framework, you also have to consider that there come a lot of benefits with client-side routing. And the first thing is that browsers do a pretty decent job of making technology accessible for everybody. And when you're using, for example, client-side JavaScript routing, you have to consider that you are then allowed to re-implement an accessible navigation. Because you're just replacing the DOM and you're updating the URL, and assistive technology, like for example, a screen reader, doesn't actually know what's going to happen, and then people are just lost. So in case you're using client-side routing, the people from Gatsby did a little bit of research. So what you should do if you're using React, Angular, Vue, or any client-side JavaScript framework and you change URLs, first of all, you should provide a proper skip link so that people can navigate content easier, but also you should include an HTML element that is an ARIA live region, and you update that too. So that people using assistive technology then get a notification which is like, hey, by the way, you click this thing and you're now on a completely different page. And I'm a big fan actually of client-side routing because I would love to see more of these kind of beautiful experiences where something morphs into something else and transitions from one route to another that just make me smile because it's delightful. And these things are possible to build for the web. So what you see here is a prototype by Sarah Dresner built in Vue. And I love that. This is just fun to click around. This sparks joy, right? But this is not what we're using client-side routing for. And it is surprising that even Ryan Florence, who is one of the co-authors of React Router, says that he might believe that client-side routing is usually not the preferred way to build for the web. But there are also good examples like this one, for example. When you go to the Vue.js documentation, you will find out, and when you navigate, that they're not using client-side routing. And I want to believe that this is for the reasons that I just mentioned. Overall, I think the important thing is that a great site should just work. And to make a great site that just works, I 100% believe that you still have to know about the foundation of the web, which is HTML, CSS, and JavaScript. A great site doesn't have to be built with React, Vue, and Angular. And when we're making technology choices, maybe we should think about the end goal. When we ask ourselves what we should use to build the next project, we shouldn't think about using a framework X with server-side rendering with an offline strategy because everything needs a service worker these days and it has to run in a function somewhere on the edge. Maybe the answer should be, as always, it depends. What's your use case? A great site can be built with React, Vue, and Angular, but I think it's more important that a great site is accessible, fast, and secure. And if I can say one thing, I would really like to get rid of this sentence, that something is just HTML. HTML by itself defines over 100 elements. HTML input elements have 22 different types. And there are new additions coming every now and then. So for example, what you see here is the enter key hint attribute, which with you can control the submit button of virtual keyboards. Chris Coyer wrote a 4,000 word article comparing links versus buttons. And at the same time, we as an industry rewrite markup like that. That is not very great markup. HTML is not easy. And when you look at the accessibility spectrum and look, for example, at the Millions projects from WebAIM, so they are an accessibility nonprofit, once a year they crawl the internet and they see how accessible the web is today. And you see that there are a lot of detectable accessibility issues that are based on HTML, going from empty links to missing form labels to empty buttons. And when you look a little bit under the hood, you will find out that sites that are built with a JavaScript framework are usually performing a little bit worse accessibility-wise. And this is not the developer's fault, because when you think about the whole spectrum, you cannot know everything. And when you have a lot of complexity because you're using a framework, of course, something will suffer of that. When you then have a look at the overall statistics, you will find out that 98% of the web have detectable accessible issues. And it feels like we're just getting worse and worse and worse. And every now and then, we then have these kind of news headlines going around, where one or another third party was hacked and hundreds of sites are mining cryptocurrency. And this is funny because we have a security mechanism in the web in form of content security policy. You can use content security policy to really nail down what is allowed in your website. And if something goes hacked, you have a safety net to block these kind of things. But when you then look at how many pages are actually using CSP, you will find out that it's not that many. And we include more and more dependencies that we forgot to update, and that then include vulnerable JavaScript snippets that can be exploited by any person that knows how to do that. Overall, I feel like the web loses quality. But hey, I mean, at least developers get more productive, right? Everything changed when we started using Node.js and NPM because we got these new tool chains, new ways to build for the web. And I deployed my first Node.js service to Heroku because I'm not a DevOps person, so Heroku did that for me. And now we have services like Netlify and Vercel. And now we're entering the serverless era, which is extremely exciting because now front-end developers can build or write a serverless function with 3 lines of JavaScript or maybe 6 lines to push it to the web and build their own API endpoints. And with the technologies that we have today, the options to build a product very quickly and for free are limitless, right? We could use something like Google Analytics or something that is more privacy focused, maybe. You could use Contentful for getting some content in. You can use Firebase to have a storage in cloud. You have Sentry maybe for error monitoring. You can use Algolia for having a nice search that you don't have to worry about. And the list goes on and on and on and on. But then at the same time, what we did is that our hello world with maybe 10 kilobytes moved to a hello world with 40 kilobytes. And maybe I would be okay with that. But then at the same time, we increased the complexity of the things that we have to deal with tremendously. So when I'm now looking back at the side project that I was building, Tiny Helpers, what I provided was an NPM script so that people only had to do NPM run add helper to add a new helper to the file. And one person was actually pointing out, this is nice experience and stuff, but Stefan, I had to download 700 megabytes of Node.js stuff to add a JSON file to this project. Maybe we're getting a little bit overboard here. And I bet that the person maintaining this site only uses a text editor. Whereas my own site, I need a text editor, I need Node.js installed, I need NPM installed, I need framework knowledge. And if I wouldn't touch this site for a few years, I can hope that I don't have to update a single dependency and then spend a day chasing things that have been broken. Josh Kamor once said that building for the web, that it never has been as easy to build complex apps. And I agree, it is beautiful. But how many things that we build actually have to be complex apps? And where are we going with this trend? When I started, I was dealing with MySQL, PHP, Apache, and jQuery. And people that enter the industry today are dealing with this wall of technology. They have to know the fundamentals, they have to know the frameworks, they have to know the build tools, they have to know a little bit of hosting. And it feels like complexity is king. And what are we doing that for? So when I was building Tiny Helpers, what happened is that I started out with Preact and I had everything running in a function. And at some point I was just like, what are you doing that for? Because the only functionality I had in there was a little menu toggle that opens and closes the hamburger menu. And Jason Miller, who is the maintainer of Preact, agreed with this sentence and was like, yeah, even Preact is a little bit overkill for this case. And maybe we have at some point a build chain that can just optimize everything away when it's not useful to the user. So what I ended up with was 16 lines of handwritten JavaScript, and the rest was static HTML. So maybe we will have good enough abstractions one day, but today I still believe that we still have to know fundamentals to create the best user experience. And depending on the company that you're working at, you always have to remember that with the technology choices that you make today, you're shaping the job market of tomorrow. And I want to believe as a front-end developer that my job is to build beautiful experiences. But it turns out that my job as a front-end developer is more to choose what tools to use, what frameworks to use, what to prioritize, and then find a way to maintain all these complex things that I've chosen. We have people in the industry that work in the field but don't know how to build a website. And it is not their fault because we're just building overly complex things that don't need to be as complex. This whole list is just way too long and way too much things to know. Chris Coyer wrote this really nice article that is called The Great Divide, and he kind of feels that the term as a front-end developer is maybe not fitting that much anymore, because maybe we have two camps of front-end developers these days. We have on the left front-end developers that care maybe about JavaScript stacks, maybe about GraphQL, maybe are into JavaScript architectures. And then on the other hand, we have people that care about user experience, about accessibility, about CSS architectures. Maybe it is time for our industry to realize that front-end developer is not a thing anymore because we have too much things going on. And there's really the one thing that you maybe can take away from this talk here, that your users really don't care if what you use to build things. Our job to build for the web is to care about user experience. But I feel like over the last 5-6 years, we kind of lost track a little bit and we care more about developer experience and we ship more and more. So to close the whole thing, I really love all these tools that we have today, and I love writing JavaScript. But maybe it is time to take a step back. And maybe we should consider the right tools for the user experience. So where did that bring me? So I had this site running from 2017 to 2020, and I dropped it completely and rebuilt it from scratch in 2020. And this is now using mainly static HTML. I reduced the overall page weight by 64%. This is Jamstack site, so a static site that is generated by a build server. I reduced the build time from 4 minutes to 40 seconds. I don't have a JavaScript pipeline in there like at all. And I feel relieved because I'm dealing with a reduced complexity overall. And if I need something, I'm going for web components. So what you see here is the time ago web component. This is maintained by GitHub. And if the JavaScript for this component is loaded, it will show something nice like 5 hours ago, 2 days ago. If not, it will just show the date in a readable format. I'm now part of this anti-JavaScript club because I love writing JavaScript, but I don't want to write it when it's not enhancing user experience. And overall, I'm now dealing with a complete green lighthouse score, which I'm actually very proud of because it gives a better site with a better user experience. So Stefan, is a JavaScript stack really that bad? Not at all. But maybe we should focus more on building sites that just work. And maybe we should worry less about the technologies to build these. If you want to have a look at these slides, they're available under my links online. And yep, this person owns this domain. Did we lose the right direction? And I'm Stefan, I'm working for Contentful, and thank you everybody for listening.
Awesome. Thank you, Stefan, for your presentation. And I cannot agree more with you. We're building too much complexity into the web apps today. I have a question. What do you think of the AMP project, which essentially tries to
You want
reduce?
to get controversial here, yeah?
I'm curious.
Well is I'm not a fan. So AMP is basically reinforcing good practices with JavaScript, right? So it's not building on the native web. So I'm not the biggest fan. It's also Google is changing now how AMP goes or how they treat the news carousels, right? So also fast sites can now go into the news carousels. That was beforehand not possible, which was just a monopole move in my opinion, because they forced AMP on the site builders to get into the news. So I'm not the biggest fan of the AMP project because I think things should be standard driven. AMP by itself, though, had a nice impact on the web community because people figured out that they have to compete with AMP sites, and AMP by itself is performing not too bad. So I have to give the team give the team that. But for example, AMP limits functionality that you can put into sites. When AMP was released, we got a new spec out of that, which was the feature policy spec, so that we can have certain things that are just reactions to Google pushing AMP. So I think this was a good thing. And overall, I think that in the long run, I hope that AMP will be dropped because now that Google search, for example, also considers lighthouse scores in the ranking, I think that people have to build faster sites anyways to rank good in Google search. And with this, I hope that people discover that building a fast web is a better web. And maybe we don't have to re-implement non-standards with AMP.
Yeah, I completely agree. I think the web was getting super slow, and then Facebook instant articles come by. Although it was another monopolistic move, Google had to react with AMP, but that taught us that we definitely need to make faster websites, and
Yeah.
that's possible without bulking hundreds of megabytes into a build to get a few megabytes worth of website that opens a few
For a little bit of text and images.
carousels.
Yeah. Yeah.
Yeah. Thank you, Stefan, for your awesome presentation. It was amazing. People are also saying that we can add more hardware, we can add more to the deal, but I think people that also build the software that took us to the moon are like super not proud of what we built with the web. Thank you again for your presentation. Next, we'll have Etti again joining us. Hope her internet connection is back.
Should I drop out now, or what should I do?
Yeah, sure, you can drop up. Thank you
well,
very
then,
much.
Thanks so much for having me.
Thank you as well for joining us. I'm going to share your links on our group, Talks by Softinator, and if people have more comments, they'll probably comment there on your links, and I'll ping you back when they do. But thank you again.
Yeah, I'm best reached via Twitter, right? I'm a Twitter addicted person, so for the Twitter people.
For the Twitter people. Although in our country, Twitter is not that popular, maybe it starts to pick up a bit. But yeah, definitely we'll ping you on Twitter. Thank you again, Stefan. It was a pleasure. Bye-bye.
Bye.
As I said, Etti will be joining us again, hopefully, if her internet connection is back to normal. Let's see how that goes. And hello, and welcome
My
back.
internet went back down again, so
oh, damn.
I hope I can go forward using my hotspot.
So you're on hotspot.
So I apologize.
You just got stuck again a bit, but now it seems okay. Hopefully your hotspot is okay.
Yeah, there's some kind of storm going on around, so.
Okay, so yeah. Etti Gur, welcome. Welcome to Talks by Softinator. As I said at the beginning, Etti Gur is from Israel, highly experienced developer with 20 years in the software industry, currently a senior big data engineer at Nielsen, built a lot of big data pipelines with Spark, Kafka, Druid, Airflow, and more, and she will be talking about optimizing Spark-based data pipelines. So, Etti, before we start, you can talk a bit about yourself and how did you end up tackling big data?
Yes, so I'm in the software development area for over 20 years. And in the last 8 years, I started working at a startup named Excelate. And there I started being exposed to big data, what it was at the beginning before the technologies we know now. We started working with many small Java processes that are working. Each one is working on a separate part of the data, and everything's trying to be consuming all this huge data, but with all technologies. And on Excelate, we started learning the new technologies that are available for us in big data, and we started learning Spark and all distributed processes. And then it got us to working with Kafka and Druid and many more technologies.
Epic. That's pretty nice.
Yeah, it's crazy. It's crazy to see it from the start.
So you'll be sharing with us how to optimize some Spark data pipelines.
Yes, some basic ideas and a few interesting tricks and things we find during tackling some.
That's great. We have some Spark fans in the community, so I hope they'll enjoy it. You can go into your presentation. They'll definitely enjoy it.
Okay, so let's I'll present. So can you see my screen?
Yep, it's looking good. That's great.
Wonderful. So let's start. So thank you for joining the session of optimizing Spark-based data pipelines. So as you introduced me already, I'm Etti Gur. I'm a senior Big Data developer at Nielsen Marketing Cloud, and been dealing in the last 8 years with many big data challenges. So what we're going to talk about today, how we basically optimized our Spark data pipelines using ideas such as optimizing Spark resource allocation and utilization, parallelizing Spark output phase with dynamic partition inserts, and running multiple Spark jobs within a single Spark application. So a little bit about the NMC. The NMC is a group within Nielsen that's based on a startup named Excelate that was acquired by Nielsen a few years ago. We're a data company, which means we collect data on devices from our partners in various ways, online and offline. And we process and enrich this data using machine learning models for insights. And we basically allow our customers to target the relevant audience and make better business decisions. A few numbers about the NMC. We ingest over 10 billion events per day to our Kafka streams. And this data is then translated onto our data lake AWS S3 storage with 60 terabytes of Parquet files per day. We process and enrich this data using Spark with around 6,000 nodes per day. And we ingest tens of terabytes per day of processed data into our Druid analytical database. So this presents us with many challenges, such as scalability, fault tolerance, and cost efficiency. And these challenges are relevant when we want to build a new data pipeline in production, but they are also relevant when we have older pipelines that have been running on production for a while and been running smoothly, because after the time goes by, the data keeps growing, and sometimes we change the code and the infrastructure is evolving, and we find ourselves having to re-optimize our data pipelines. So before we talk about optimizing Spark applications, let's just mention what Spark is. So it's an analytics engine for large-scale data processing. It's distributed and highly scalable. It's a unified framework for batch, streaming, machine learning, etc. So a few terms, the Spark application is consisted of a few elements. The Spark driver, which is the application main program, and Spark executors, which are distributed worker nodes, worker processes that are responsible to running the individual task, the units of work. The Spark application is running on a set of machine, a cluster, using a cluster manager such as Mesos or Yarn or Standalone. And managed Spark on public clouds examples are AWS EMR, GCP Dataproc, and more. So the data pipeline we're going to talk about today is used to analyze advertising strategies on advertising campaigns while the campaign is running. So let's start with the logical phases of an advertising campaign. The first stage is awareness. The user is exposed to an ad. The next stage is consideration. The user is expressing some kind of interest, like clicking into the homepage. The next stage is intent. The user is taking steps towards making a purchase, such as clicking into a product page. And the final stage is purchase. In the ad tech industry, this kind of flow is called a funnel. And this is because if we have many users exposed to an ad, not all the users will go forward in the flow. The number of users that will go through to a purchase will get smaller. So we want to measure our campaign's advertising strategies while the campaign is running to see which ads are more successful and are getting us more users to reach the purchase stage. So this is the high-level architecture of our pipeline. So it starts from left to right. It starts with the data lake, the AWS S3 storage with raw events data that are partitioned by date. The first Spark application is the MAR generator. The MAR generator is basically once a day reading the latest date of raw events data, creating a data mart for each campaign that is currently running, and writing the data marts for each campaign for that date back to S3. So just to mention the term data mart, it means a projection of the raw events, such as going through some kind of transformation or aggregation, and that's called the data mart. So after the mart generator is producing its marts, we have the next stage, the enricher. The enricher is another Spark application that is running on one campaign each. And its job is to read from S3 the marts data of that campaign and the older marts, creating and enriching the data by creating the structure of the funnel we talked about before, and writing the enriched data back to S3 to be loaded to Druid database. The problems in the pipeline, I have to say that this pipeline has been running for a few years on production and it was quite stable. But over the time, as I said, the data grew and the code changed, and we found ourselves with a data pipeline that is causing a lot of problems. So it started to have a growing execution time, and it sometimes exceeded the 24 hours per day, which is unsustainable. And it was getting very unstable. It had many sporadic failures, especially out-of-memory failures. And it had high costs that exceeded the $30,000 per month. Each incident was also very exhausting to recover from. So when we approached to optimize the data pipeline, we started with the mart generator. So again, the mart generator is reading the latest date of raw event data, producing marts for each campaign for all the campaigns, and writing the marts for each campaign back to S3. So the specific problems in this application were that it was running for over 7 hours per day, and it experienced sporadic out-of-memory failures. So before we talk about this specific optimization, let's just talk about a few examples of what tools we have to examine Spark resource allocation and utilization in order to optimize it. So the first tool we have is Spark UI. Spark has many dashboards, and especially the executors tab it can help us. Spark is also producing metric system. So we can consume these metrics using JMX or Graphite, and to see trends over time of our Spark application performance. If we're running with Yarn as a resource manager, we can also use the Yarn UI, and we can use cluster-wide monitoring tools such as Ganglia. So I'm going to show you a few tools. A few of these tools. Here is the Spark UI. In the Spark UI, we can see memory and CPU consumption and allocation. This is how the Yarn UI looks like. It has a lot of data of also memory and CPU allocation. And if we look closely at a Yarn UI example, we can see that we have a process that is running on the cluster. And on the top row, we can see the cluster has around 500 cores, and only less of them are being used by our process, are being allocated to our process, which is very bad. We're using less than half of the cluster CPU. Again, in the node level, we can see in the bottom that on each node we have 16 cores, and the process is actually allocated only 7, which is also very bad. Also in the Yarn UI, we can see the memory allocation. This is how the Ganglia looks like, which is a cluster-wide monitoring tool. And if we look a bit closely, we can see the CPU utilization. And this is actually shows the CPU utilization of the mart generator. And we could see it was not utilizing the cluster very well. At the beginning, it's utilizing only 50% of the cluster. And later on, the cluster is practically idle. So let's try to understand why it was running so poorly. So the initial resource allocation for the mart generator was, it was running on an AWS EMR cluster with 32 worker nodes of i3 8 extra large. It Each node had 32 cores and 244 gigabytes memory and very fast SSDs. So the configuration for the Spark were having 6 cores per executor and 40 gigabytes memory per executor. The default for memory overhead per executor is 10%, so it's been 4 gigabytes. If we calculate this, we can see that we had 5 executors on each node, leaving 2 cores unused, and leaving 24 gigabytes of memory also unused. So over the cluster, we had almost 800 gigabytes of memory not being used, which reminds us the out-of-memory failures, and 64 cores also unused. So how can we better allocate resources? So after we decide which machines we want to put in our cluster, we have to think according to the machine details of how many cores it has and how much memory is available, to do the right division of giving each executor the number of cores that if we divide the total cores to the number of cores per executor, we would not have any remaining cores unused. And after doing so, let's look at the example of i3 8 extra large. We can see we can define 8 cores per executor. Therefore, we would have 4 executors on each node and having no cores being unused. And then we would take the memory that is available for us and we would divide it by 4 for each executor and decide by this number to give it to the memory per executor. So all of those examples are basically the same. We can do on the same instance type different configurations, like doing on the i3 8 extra large 4 cores per executor and having 8 executors on each node and dividing the memory accordingly. So let's look a bit more visually on this because it's a big table with many details. Again, the example of i3 8 extra large node, it has 32 cores. In the middle, we can see the 4 cores executors per executor example, and we can see the cores are being divided to executors, leaving to 8 executors, leaving no cores unused. And then we can see in the bottom the division of the memory to 8 executors. And here is another good example, the 8 executors cores per executor, which gives us 4 executors and dividing the memory accordingly. And in the right, we can see the bad example of the Mar generator that had 6 cores per executor, and this resulted in having 5 executors and leaving 2 cores unused. And also the division of the memory was also not optimal, leaving 24 gigabytes unused. So after we improved the allocation and by doing the right configurations for the Spark, we went back to the Yarn UI and we could see we had a success. We saw all the cores in the cluster are totally used, leaving 0 cores available, and most of the memory was also allocated to our process. We can see that in the high level and also in the cluster level and also in the each node level. And then we decided to look at the ganglia to see how we optimize the resource utilization. So we had good news and bad news. The good news were that in the beginning of the process, we saw utilization of over 90% of the cluster, which is amazing. But then we saw we had a process that is underutilizing the cluster for a few hours, leaving a long tail. And then we had to look at the code to understand why this happened after we improved the allocation. So we understood by looking at the code that the main process, the main calculation, is actually the small part in the beginning that is utilizing all the cluster. But then there was a process that was writing the Mart's campaigns one at a time to S3 in a sequential way. So to understand why this happened on production, let's go back to what the Mar generator is actually doing. So it's reading from the data lake the latest data of the raw events, creating for all the campaigns their marts, and writing the data using overwrite in case of a failure to S3, And it would write for each campaign its specific date folder. So if we're running on the 8th of December date, then the output would be for each campaign the folder of the 8th of December. The other dates we can see here are the older marts that have been created by the mart generator in older runs. So if we have a structure such as this as an output, the trivial implementation in Spark would be taking the whole data frame that holds the data of all the marts for all the campaigns, to write it partitioned by campaign and date with mode overwrite to the marts folder, to the root folder. This would result in output being written in parallel, which is amazing. But the problem with this solution is data loss, because the whole root folder will be overwritten because we did overwrite and we're writing to the marts folder. So we would lose in this solution the older marts, and this is something we could not have. Therefore, it was not used on production. The solution that was running in production and creating the ganglia graph we saw was the naive implementation. So the big data frame was, after being calculated, it was divided to small data frame. Each data frame represents a campaign's mart and put into a map. And each element in the map, each data frame for each campaign, was written directly to the destination folder of the specific campaign and the specific date. Therefore, we managed to overwrite only the relevant folders, but the problem with that was the extremely long tail and the long execution time. So to optimize this issue, we used an implementation in Spark that started at Spark 2.3 that is called a partition overwrite mode dynamic. Once we configure this configuration to be dynamic, we could go back to the classic solution of Spark of taking the whole big data frame with all the marts of all the campaigns, writing it partitioned by campaign and date with mode overwrite, the same code we saw before, to the marts folder. But once we did this dynamic thing, not only we could output the written the output being written in parallel, we managed to overwrite only the relevant folders, and the older marts were not harmed. So this was what we wanted, and the solution, the result was amazing. It was reflected in the ganglia. We could see that the process was running for a very short time, and it was fully utilizing the cluster. So to summarize this optimization, we had better resource allocation and utilization. Execution time was decreased from over 7 hours per day to 30 minutes. We stopped having sporadic out-of-memory failures, and we managed to overwrite only the relevant folders. So after being so happy, we had to still deal with the other big problem we had, which was the enricher Spark application. So let's remind ourselves what it does. So what it does is reading files of the marts for one campaign. It's actually running for one campaign. So it's reading the marts of the campaign, the new marts and the old marts, and it's writing the enriched data back to S3. It's enriching the data and writing it back to S3. The implementation that was done on production to do so was to have one EMR cluster, and through a Python script, submitting many Spark applications on that specific EMR. And each Spark application would deal with one campaign that is currently running. So the problem in this application, the main problem was that it was running for a very long time each day, and it started to exceed the 20 hours per day. So to examine what exactly is wrong with it, we started with the ganglia, and we could see immediately that it was problematic. We could see that it was the cluster was underutilized, and we could actually see the Spark applications running one after the other, and none of them is utilizing the cluster. So we wanted to think of a way how we can save ourselves some work and not changing much of the code. leaving the enricher to keep running on one campaign, but how we can parallelize these many processes all together. So there could be many solutions for such a problem. We decided to go with running multiple Spark jobs within a single Spark application. So to do so, you would have to create one Spark application with one Spark context, create a parallelized process such as a thread pool, and each thread should execute a separate Spark job, and they would all run in parallel. So jobs will be waiting in queue and will be executed based on available resources. And this will be managed by the Spark scheduler. So this is how it looks like in the main program, the new code. So this is a Scala code. And we would start with a list of the campaigns. So when I say list of the campaign, it's actually something very simple that has, let's say, the campaign's names or codes. So we take this list and we do par, which means we parallelize this list. So for each element in this parallelized list, we would run a separate Spark process that would process this specific campaign. And this process would actually do a Spark read into a data frame, a Spark process, and then a Spark write back to S3. And because we did the par, this whole thing would run many Spark processes at the same time. And when we look at the Spark UI, usually when you have a regular Spark application that is not running multiple jobs at one time, you would usually see one active job at one time. But in our case, after running this code, we could see that in the Spark UI, we had many processes running, many jobs, Spark jobs running at the same time. So here we can see actually 30 campaigns and 30 Spark jobs actually processing these campaigns at the same time. And then we looked at the ganglia, and we actually see this worked. We managed to run all the processes at the same time, and all the processes were actually utilizing fully the cluster. So this actually was utilizing the cluster, and accordingly was running for a very short time. So let's summarize the results in this Spark optimization. We managed to run multiple Spark jobs within a single Spark application. We had better resource utilization, and the execution time was decreased from over 20 hours down to 30 minutes. So let's go over this whole data pipeline optimization. We had a pipeline that was running for over 24 hours per day, and it was reduced to 1 hour. We had many sporadic failures, and this almost was gone. The costs were reduced from over $30,000 per month down to $2,000 per month. And if we still have incidents, they're not exhausting at all. We can deal with them in a few minutes, up to 30 minutes. So we basically had over 90% improvement and savings of $370,000 per year, which was amazing. So let's go over the things we learned. You too can optimize Spark resource allocation and utilization. Just leverage the tools at hand to deep dive into your cluster. Spark output phase can be parallelized even when overwriting specific partitions. Just use dynamic partitions inserts. And running multiple Spark jobs within a single Spark application can be useful. And the most important thing is that optimizing data pipelines is not an ongoing effort. It is an ongoing effort, and it's not a one-off thing. So before I leave, I want to hand you a few links. Women in Big Data is a worldwide program that aims to inspire, connect, grow women in big data and analytics fields. It has over 30 chapters and over 17,000 members worldwide. Everyone can join regardless of gender, so find the chapter near you in this link. And here are three talks, very interesting talks by the NMC guys that are on topics that are related to the topics I talked today. So it could be very interesting if you want to hear more. And the NMC Tech blog on Medium is also very interesting. So I encourage you to click and take a look. So thank you, everyone. And you can, if anyone wants me, I can share the slides and answer some question. You can contact me on email.
Thank you, Etti. It was an epic presentation. Those were quite some cost reduction. So you saved the company quite a lot of money.
Yeah, it's an amazing feeling.
Yeah, I bet, especially seeing the CPU usage near 100%. Although I'm not doing big data, we're processing a lot of video, so a lot of AI and video editing. So we're trying to, when we process video, to be as efficient as possible in the same way, like high CPU usage and finish as soon as possible. Thank you for your presentation. Yes, if you can send me the link to the presentation or the last slide to copy paste it so I can share it on the group as
thank
well.
Thank you for having me and with all the internet issues. So thank you very much. I really appreciate it.
Thank you as well. Your presentation was great and it eventually solved you had the network issue solved as well. So everything's great when it finishes great. Yeah, I will share the links with the group, and if they'll have questions, I can invite you as well in our Facebook group. For everyone that isn't in our Facebook group, Talks by Softinator, join on our Facebook group. We're recently starting to reactivate our LinkedIn group as well, because we have quite a few people that don't really like Facebook, so we're trying to broaden to LinkedIn and YouTube as well. Thank you as well for your presentation. It was great, and I guess this is the end of Talks 141. Have a great holiday, everyone, and Merry Christmas, and see you all next year, I guess. And thank you again, Etti Gur.